right, good afternoon or good morning, everyone. Thanks for joining our webinar on how to launch better software with froglogic quality assurance webinar today. If you have any questions during the session, please submit them using the Q&A button at the top of the interface. Those questions will be answered at the end. This webinar will be recorded and you'll receive a copy of it delivered to your email account. I hope you enjoy, and I'll now hand you over to our experts. Over to you guys.
All right, hello everyone. Welcome to the webinar. My name is Petteri Hollander. I'm the head of Qt Ventures organization with the mission of finding new business areas and extending existing business areas with new offering for the Qt company. Today, I'm very proud and excited to welcome froglogic to be officially part of the Qt company after last week's acquisition. froglogic has been an integral part of the Qt ecosystem for its whole existence. And today we give you the overview of what froglogic quality assurance tools are all about. So let the show begin.
Okay, thanks, Petteri. Hey, my name is Reginald. I'm one of the co-founders of froglogic, and I will walk you through the webinar today. But we have a few more people from our side here as well. So, Harri.
Yeah. I'm Harri. I'm the other co-founder of froglogic, and I'm very glad to have joined the Qt team now.
And Tomasz Pawłowski here. I'm a Squish technical consultant at froglogic, and I'll be happy to present a Squish Gui Tester.
Yeah, and I'm Nico Kaufmann. I help manage and develop the Squish Test Center project.
Okay, thank you. Then let's get started. So today in this webinar, we will just say a few words about who we are for those who have not heard about us yet. And then we will dive into the three products which we are offering and which are now part of the Qt company. So that would be probably our most known product, Squish, for automated GUI testing. Then we will also talk about our Coco tool for code coverage analysis. And finally, about Test Center, which is a rather new product, which we just launched last year for the management of test results and further analysis. And then towards the end of the session, of course, we will also run a Q&A session so you can ask any questions which you may have about our products. So about us, about froglogic, both Harri and myself, we are coming from Trolltech, the predecessor of the Qt company. So we worked there as software developers on Qt many years ago. In the year 2003, we founded froglogic with the goal to create a tool to automate testing of Qt applications. Especially back then, there was nothing like that in the market. Pretty much all tools only supported native Windows. And that's why we saw a need there and founded the company based on that idea. Over the years, we always kept very close ties to Qt, so that always was the biggest and still is biggest and most important market for us. But we also expanded into other areas. On the one side, supporting more technologies for automated GUI testing than Qt. So if you want to test other types of GUIs or HMIs, and also adding more products to our portfolio beyond GUI testing. So as of today, we have a pretty large and growing customer base pretty much all around the globe. And of course, with joining forces with the Qt company, we plan to further expand on that. And as already mentioned here, last week, we have been acquired by the Qt company, and we are very excited to be there now, since we think that's, of course, the perfect match to join the Qt company with our tools. So then let's move forward to our main product, the Squish Gui Tester. So why does someone need the Squish Gui Tester? As everyone who develops user interfaces knows, testing user interfaces is an extremely time-consuming and error-prone task, and no one really wants to do it manually, not only because it's boring, but also because it really takes a lot of time. And especially with the rise of a lot of touchscreen devices from automotive to medical industry, but also lots of small gadgets everywhere you find touchscreens, more and more user interfaces are created. And of course, all of that needs to be tested. And in order to be able to release software in a reasonable, timely manner, the only solution there is, of course, to automate the testing of the graphical user interfaces. So you can run a lot of more tests in a much shorter time. And unlike with manual testing, where you would find regressions only towards the end of a release cycle by running part of your continuous integration, for example, you will find those regressions much sooner, making it much easier to fix. Now, we don't claim that automated testing is a boost from the start. So one thing everyone has to realize is, of course, that investing in automated testing means that initially it will be more effort to get everything up and running, create the first automated tests, create a framework around everything. But once that is in good shape, the effort to continue maintaining and adding new tests will be way less than continuing to manually test. So there is an initial barrier for sure, but there soon comes this break-even point at which point automating tests really pays off. And that's really what we are basically looking at. Now, more specifically about Squish, as I already mentioned initially, we initially focused on automated testing of Qt applications. So we have been a cross-platform tool from day one, running on Windows, Linux, macOS, still several Unix platforms, all kinds of embedded systems, mobile systems. But we also expanded the technology support from Qt to also pretty much everything you can think of, which you're able to create a user interface with. Now, specifically for Qt, we have very dedicated and Qt support, of course. Since we are in the market for quite some time, we still support back to some Qt3 versions. There are still people using that, if you believe it or not, and support all the way up to current Qt6 releases. So we're always on top of what's happening in Qt and making sure that Squish can be used to automate any type of Qt applications. So that, of course, means we're still and of course continuously supporting Qt widgets, but of course also QML and Qt quick applications. So either technology you're using is well supported by Squish. We understand all the standard controls, complex controls, even stuff like Qt WebKit, Qt Web Engine can be automated. So we can then drill into the DOM tree of that, for example. And if you derive controls from Qt controls, we support that. We have introspection into into Qt, so you can access all properties, all methods, all slots, and so on and so forth. So that's pretty powerful there. As for the test setup, Squish can be, of course, run on the same machine as you are automating the application, but it is also possible to do so-called remote testing, where you have the Squish tools on one machine and automate the application. That could be a desktop application, but also an embedded or a mobile application on a remote target or remote machine. So that's a very powerful feature that you can do distributed testing, really automate the final target if you are working on some embedded project. And then finally, before we head into the short live demo, just a few feature highlights of Squish. So what's very important in GUI testing is always how does the test tool actually interact with the application. And there we really support Qt as such that we can drill down into the application, and based on all the properties, we can uniquely identify objects and interact with them. So no image are taken for identification, but we work based on properties. But as a fallback, we can also do image-based testing based on image comparisons and object character recognition. On top of that, we offer all kinds of verifications, starting at property verifications up to visual verifications and more complex types of verifications. Squish test scripts, as you will see in a moment, are written in one of several offered script languages, so that's very powerful. And on top of that, we offer something called BDD, behavior-driven development, which is an abstraction to abstract the test logic from the implementation.
Reggie, could you maybe stop sharing for a second and restart it, because I think your slides are frozen for.
Oh, are they? Okay. Which slide are you seeing?
Complete Qt support is what we are seeing.
Okay. So I will reshare. Can you see it now? But either way, I will just continue with the features. So we do support testing of several applications. So it's also important for several scenarios where you're not just having a single application, but for example, test a companion app of some device and want to do a system test of that. We have integrations into several CI systems and ALM systems. And finally, for the safety critical industries, we also support tool qualification, so you can actually use Squish as part of safety standards. And with that, I would stop sharing the screen and pass over the control to Tomasz to do a live demo of Squish. Tomasz.
Thank you, Reginald. So I was asked to present you a Squish Gui Tester in just 10 minutes. It's not an easy task because the tool is very mature and offers many features, capabilities, configuration options. So I could talk about it for 2 days. So such a short demo will just give you a first glimpse of what Squish is capable of. So as Reginald said, currently graphical user interfaces are complex and they expose a lot of functionalities. And of course, as developers, testers, we need to make sure that our user interface actually looks and behaves as extended. So my camera is not pointing on my face, it's pointing on the device. And on my desk, I have a tiny ARM IMX6 device running Qt-based application. We call it the company Greenbox, so the color matches perfectly both froglogic and Qt. Let's take a quick look at the application user interface. So the application running here, you have 3 indicators. I can set a speed. Here I can set a heating using this slider, and as a result, the current discharge power is calculated. So that's a nice functionality. And I would like to present shortly how we can test this functionality. So let's now use a Squish Gui Tester and write scenarios which will verify that this discharge power is calculated correctly. We'll use behavior-driven development and testing approach to design such tests. So in this approach, we describe a test first using plain English and which follow Gherkin syntax. So first, let me create a new VDD test case. It shows with some template scenario and the feature. I will just replace that with my own feature. And in my test case, I would like to verify that when my application is running, when I go to the correct tab, I set a speed to 20 kilometers per hour. I set a heating to 25 degrees. Then the discharge power should be 9 kilowatts. As you can see, there are warnings here being displayed. This means that those steps are unknown to Squish. So now we can manually code them, or we can simply record them. So it's very easy. I just click the record button next to the test case, and now you can see that I can need to choose my application, which is a green box. And now you can see that my steps are being displayed, and I can easily record them. And the first step is that the electric car application is running, and this is this is of course already happening. So I just click the arrow next to the step, and then I can record the next step. And the next step is that the gauges tab is open. I just interact with the application. So I will just tap the gauges tab, and I'm done. You can see the click tab was recognized, and I can click the arrow to go to record the next step. And with the next step, I need to set the speed to 20 kilometers. So I'll try to do it precisely, and I'm done. I go to the next step. I will set a heating to 25 degrees, pretty much about, and then I'm done. And now there is a step when we want to verify that our application behaves as expected, and to verify to verify the expected results of given scenario, we need to add a verification point. With Squish, you can verify object properties, for example, a text property, value property, or any property that a Qt object can have. You can do a screenshot comparison. You can verify content of the table, and finally, you can do a visual verification. The newest addition to Squish verification capabilities are search image verification and OCR text verification. So let's choose a property verification. We would like to verify the object property. We are back to Squish IDE. Now we need to pick the object that we want to verify. The easiest way is just to use the picker tool, and I can just easily pick my object that I would like to verify. You see the object is picked, and on the bottom right, I see all the object properties and the current values, and I can verify any of them. I will look for the value property, and I will check the property, and I will click Save and Insert Verifications. I'm done with the recording, so I can click Stop Recording. So after recording is done, you see that warning disappeared, and for each step, a function with Squish API code was added. So now Squish knows how to execute this step. To take a look at the steps, I can simply click on the step from my Squish IDE, and actually here I need to modify because I wasn't precise enough during recording. So I will point the exact values that I was supposed to set. So to 25 degrees, and the expected result is 9 kilowatts. You can see Squish API commands like clicking on tabs, scrolling, different verifications. So all the interactions with the GUI controls or verifying GUI controls you will find in this step definition file. Okay, so our scenario is ready. We don't see any warnings. It means that we can replay this scenario and see if our test case passes or fails. The test case passes as we expected. The feature file is colored in green, so it means that for this scenario, everything is working as expected. Let's take a look. Let's copy this scenario and let's verify and let's create a new one. But with BDD approach, there is no need to do any additional codings. I can just copy existing steps and try to slightly modify them. So instead of now setting the speed to 20 kilometers, I will set the speed to 40 and the heating to 30 degrees. I expect the discharge power to be 20 kilowatts. You see warnings appeared again. It means that that those steps are unknown. But as you can see, that the only difference is in the test data and expected values. So the easy way to handle that is we can simply parameterize our step, and so they work with any values. To do that, we need to go to the step definition file. And then, as you can see, we can remove those hard-coded values in step text, and we can replace that with a placeholders. So add a placeholder here. I will just extend my function signature, and I will use this as a variable with the scroll to function. The same for setting the heating. I will use a placeholder and also extend my function, so heating, and then simply. And finally, the same for our then step where we verify that everything is working as expected. I will again use here placeholder and add extend the function and also add it here. Let's go back to the feature file, and now we see that the warning disappeared. Those steps are now recognized, and we can. I should also copy the scenario header and give it another name. So high value, high speed, for example. Now we simply extended very easily our feature file to second scenario, and now we have two steps with two scenarios which test different values. And now I can just run the second scenario to see if everything is working as expected. Everything is fine. Let's see if Squish works correctly. If we change the value to 15 kilowatts to improper value, let's see what happens if Squish is finding this difference. And of course, Squish reported that the value is not correct. Of course, there's plenty of things you can do. You can extend those tests. You can apply additional logic, but that is just a simple glimpse of what Squish is used for. So with the Squish IDE, you can develop and maintain your automated tests either in the BDD approach like I did, or with the standard approach. You can run your tests from a variety of CI solution or even from a command line. So then the results will be generated in different report formats. So let me quickly just finally show you the HTML report, which was generated just before this webinar. And even in case of failures in the report, you could see screenshots taken directly from a device. So you can analyze if there's a failure in my automated tests, how at the time of the failure, how the application looked like, and you can maybe try to find the answer why your test failed. Yes, I think that's everything I prepared. So back to you, Reggie.
Okay, thank you. I will then share my screen again. Okay, so now that we have seen the demo of the Squish Gui Tester, we will move on to our second product, Coco, code coverage analysis. So the typical question you're asking when you have tests, so either GUI tests, but of course also unit tests, are we testing enough, or are we testing the right things? And that's what we try to answer with our Coco code coverage tool. So basically what the tool does is that it analyzes the coverage of your source code when tests are being executed, regardless what type of tests. So basically you can see which tests exercise which parts of your source code. Out of that, you can deduce whether you have redundant tests. So there may be a lot of tests which always exercise the same code, but then you can also, of course, discover testing gaps. So basically, if there are certain parts of the code where no tests exist for, and we offer a lot of more advanced analysis on top of that. In more details, what Coco is a so-called dynamic code coverage tool. So dynamically, while you run the application, we can measure and report the code coverage. But on top of that, we also have added very basic static code analysis features, such as getting the McCabe complexity analysis. And we also have basic profiling features in Coco. So you kind of get three things in a single tool. As our philosophy always is, the tool is cross-platform, it's cross-compiler. We support a very wide range of so-called coverage levels, which shows you in very much detail whether certain expressions are tested in each possible combination or not. So depending on the coverage level, it will be more or less easy to reach high coverage of your code. And then finally, we support a few programming languages by now. So mainly C++ is what people are using Coco for, but we also support C# and also QML in case you have quick applications to also understand the test coverage of your QML code. Okay, so few feature highlights before we go on to the live demo. So the main feature of Coco definitely is to find untested code, but also you can find dead code. Very important, you can integrate it into any test framework, so it's not only coupled with Squish, for example, but if you use the Qt unit tester or Qt testlib or Google unit test framework, regardless how you run your tests, integrations are available and you can use Coco to measure the code coverage. So we are not tied to a specific testing tool. And we offer a lot of advanced analysis on top of the basic features, such as optimizing test execution by finding out which tests are actually redundant and which tests really add new coverage, and then optimizing so that you run as few tests as possible to get the biggest coverage. We offer things such as patch analysis, where we can analyze a patch for the impact on testing based on historic data. And again, we integrate into all kinds of CI and ALM systems. And also very important for Coco is the tool qualification kits. So if you're working in a safety critical environment where you have to work according to some safety standard, we offer qualification kits so you can actually use Coco in those environments and use the reports as part of your quality analysis. Okay, with that, the quick run through is done. I'm stopping to share my screen and handing over to Harri, please.
Thank you, Reggie. Okay, I'll switch to a Linux system that I've running here for this demo to also show our cross-platform capabilities. And I've picked a non-GUI application in this case, and that is a parser for mathematical expressions that I once downloaded from the net. And it can work in an interactive mode like this. So if I'm asking a question, what is 3 times 33, it will give me the answer here. And let's use this in a manual testing mode at first to show how you can now find out how much of the code is being covered during those tests. The only step that you have to do in advance is to rebuild the application in a special instrumentation mode. See, that goes rather quick. And we can at this stage already check what has the tool seen of the code that is part of the project. And I'll open the coverage browser and you'll see a list of source code files, a list of functions, C++ classes, and the source code. And everything is still gray here. Let's start with the line coverage mode at first. And you see all those lines should actually be covered for the code to be fully tested. And I will do a first test run again manually, and I will choose that example from earlier, 3 times 33 is 99. And I'm now acting as a manual tester here, saying this is all correct. And we'll now look at the coverage that we have reached with this very simple test. I'll do that by opening the execution data from this run. I can give it a meaningful name. It's a multiplication. I have verified that the test is passed, and I will import the data. Normally, this is not done interactively, maybe during the setup, the trial, if you want to look at something specifically, but all of this can later be fully automated from the command line as part of your CI system, for example. And yeah, I'm importing this run, and we see some colors showing up. Some of the files have gotten some coverage, although it's still pretty low. That's why it's red. Some medium good ones orange. And also the source code has now its first green color showing up. I can actually click somewhere, and here in this explanation window, I'm seeing which of the test has been hitting that line, and that's very helpful for analysis. Let's do a second run here, for example, using variables. So I define the variable a to be 100. I multiply one with the other. The answer is 10,000. It looks good. And I'm now expecting that this has now hit some different pieces of code. And Coco noticed a new test run. It's again a pass. I will import the data. And we see a new execution showing up here. And the power of Coco lies within the fact that it knows about the coverage of each individual test run. So it's not just an accumulation, but it knows the parts, and those parts can be compared. So for example, I could just look at an individual execution only. Or when I'm interested whether one execution actually covered more code than the other, I can enter a comparison mode choose the first test as the base and the second one as the new one. And now all the analysis has switched to a mode where only the delta between the two is shown. So in two classes, there has been some coverage. Here are some parts that are only covered by that test. Okay, let me go out of that mode and do a final manual run to also show you the patch analysis that Reggie talked about. I will do another run and I will use the factorial operation. And you may recall that 3 factorial is 3 times 2 times 1. That's correct. 1 is just 1. But now switching to 0, that's a special case. The software currently thinks that 0 is the answer, whereas it should actually be 1. So we have now a case where a bug has been found. And I will enter this. I will mark this as a failure and import it. Okay, so we have now those 3 executions, and developers or testers may further analyze the code. They may detect some dead code even, so there's a bit of static analysis there too. And the testers can also, of course, switch from better coverage levels than just line coverage to higher ones. So decision coverage is pretty popular, also called branch coverage. And here you see cases where part of the branches are either taken or not. So in this if statement, it has never been true, sorry. It always has been true, so that can be found out. And if you go into the safety critical area, we offer those higher levels like MCDC or multiple condition coverage, and I will enable that. But what you will see is that the total coverage goes down a bit, and that's actually a good sign, because that means that the higher level is more demanding and has found more cases of yet untested code. And if there is something that you know that you will never be able to test, so like some out of memory condition or so, you can also just mark the piece of code there and select to perform a manual validation, and then it will be marked in a blue color and doesn't count as untested code anymore. Okay, but let's now assume that there was enough time for the developer to fix the problem that was found, and the developer is touching one of the source code files. So I, of course, checked this before, and there's the factorial function that is lacking some exception, and I will build this in. So I'm saying if the value is equal to 0, then we want to always return 1 without any further calculations. And looking at the patch that was part of this fix, we'll see it here. And I will put this into a file, and switching back to coverage browser again, I will enter a mode where I will analyze this patch. I'll open it. The tool found it here. I will opt to create an HTML report that will be showing up here, and you see an analysis of the patch, and the 2 lines that were added are marked in green, which means there is at least 1 test, and that is listed here, that has been covering that. You can well imagine that you make this part of some review and CI system where all the changes of your development team are being monitored. Okay, but as a last measure to show you that, of course, it's not just about manual testing, I will also do a run of unit tests. And in this case, it's about a test suite that is using the CPP unit framework. So it's not just QTestlib that it's possible, also the Google test framework. So it's quite flexible there. And once all the code pieces of the library are built, I will run those unit tests. They all pass. You can see that by an OK. And there's just 1 that is failing. And let's look at how that looks like in Coco. I will import all of that through the command line. You could even generate an HTML report out of this right away. I will, this is some name for the remaining tests. I will import that. You will see the unit tests all showing up here. The failed one is marked, so you can transport over that information. And as the last feature, I will show you another usage of the individual execution, and that is the calculation of an optimized execution order. As you may have tests that take hours or days to run, by use of the coverage information, you can actually compute an optimal order, and that will happen when I press this button. It goes really quick here, and we'll see that the test for the invalid number should be executed first, and then there is the other series here, which of course doesn't add much more in the end. So if you only have a limited amount of time left, you could then also test those few. Okay, but I think I'm done with this very quick, almost brutal run through of my demo, and I will pass back to Reggie here.
Okay, thanks, Harri. So I reshare my screen, and with that, we are coming to our third product, our newest product in our portfolio, which we basically started creating after we saw a lot of customers always asking like what to do with the huge amounts of test results which they're generating. So when you start to really automate a lot of GUI tests, test runs produce a lot of results, and it can get quite challenging to actually inspect those results, find out what is really going wrong, where are the real problems, is the test flaky, or are these real problems of the application, and finding the actual issues. And that's why we created Test Center, which we launched last year, initially with the main intention to make management of test results easier. But on top of that, we also saw that, of course, integrations into other parts of the application lifecycle are useful and often requested. So we started building a bit of a platform around it, where it's possible to then connect those test results either back to the requirements or to different requirement engineering tools, so you can see in the requirements whether they are properly tested and what the results are, and also integrate that into other test management tools and issue tracking tools, so that you basically get the results automatically, or that the failures will automatically create issues or reuse issues in your issue tracking system, and basically have the link between requirements, test results, and issue tracking. And that's basically the other big feature of Test Center, which we're offering there. So basically, simply put, is Test Center is a storage of test results. So you store your results centrally on a server. Then we provide a web interface which allows you to browse those results, run a lot of analysis, collaborate, so you can comment on results, you can configure your dashboard. So there are a lot of interactive features working with your test results, comparing different runs on different platforms, and so on and so forth. And then finally, synchronize the results with requirements, test management, and issue tracking. And of course, there's also direct integration from Squish into Test Center, so you can automatically upload test results from Squish test runs, either from the IDE or the Squish runner, so that everything works pretty much hand in hand. So a few feature highlights, pretty much already mentioned them, is to store test results not only from Squish, but also from different tools, like JUnit results can be imported as well. You have access from anywhere to the results through the web interface. You have a configurable dashboard to get an overview of the project's health. There are a lot of advanced statistics, filtering, and so on and so forth. You can correlate test failures to test configurations. You get traceability with all kinds of third-party systems. And one of the latest features we added is the integration of repositories. So you can actually not only view test results anymore, but also update tests after test failures, for example, with changes done directly through the Test Center interface. And with that, I will again stop sharing my screen and hand over to Nico for a short demonstration of the tool.
Yes, thank you. Yeah, let's have a quick look at Squish Test Center. As it was previously mentioned, Squish Test Center is a web application. So this is the dashboard of Squish Test Center. This is where you can get a quick overview of your project self. If you have multiple projects, each of them will be listed here in this section. So this project is called Product C. Test results are usually executed on a CI system like Jenkins and then afterwards uploaded to Test Center. So the actual execution doesn't happen on Test Center. Going back to this view, you can configure this view to either show the most recent results by execution date, or you can sort it by upload date. Or what's really interesting is you can also, if you test your software on many different branches in parallel, you can also look at the most recent result by branch as well. So in this case, in the top row, we see that the most recently uploaded result for the 2.0 branch had at least one failure in it. So let's jump right into this result by clicking on it. Here we are now in what we call the Explore view. Right at the top of the view, we find a little pie chart summary. The summary tells us that this result consists of 9 reports. In this case, we are looking at a nightly test run that ran on 3 different operating systems and for 3 different Qt versions, which left us with a total of 9 different configurations that were tested. The pie chart also tells us that at least 2 of our test suites executed failed. So we have a good reason to continue investigating this. Which brings us to the most important part of this view, which is the pivot view. Right now it is set up to show us the test suites on the left side here and all the configurations that our tests were run on the right side. So each column here represents a configuration. So here in this first column, we see our tests that were executed on Windows with Qt version 4.8, and the configuration is shown with these labels that you can see here. These labels that you see can be freely chosen. So other examples for labels might be the browser version if you're testing web applications, or maybe a device version when your software runs on multiple embedded devices. You can freely choose whatever helps you differentiate your configurations. So if we scroll across this result view here, we might notice that looking at this many different results can still be quite daunting. And this is where the pivot comes into play. On the outer edges here, we can pivot the result view towards any of the labels that we specified. So for example, I can click on OS here to see the results aggregated by operating system. Here I can already see that the issues seem to be limited to our Windows version. And I could also click on the Qt version, and then I see that the issue is also related to Qt version 4.8 and 6.0. I can do the same thing on the left outer edge at the same time. So if I click on OS here, we now see the results aggregated by both operating system and Qt version. This is really useful, especially if you have many test cases. So in this example, we only had 7 suites, but if you imagine hundreds of test cases, this becomes really useful. So the primary use of this view isn't the actual failures. It's about the correlation between failures and the configurations your tests have run on. But I think it's time to look at the actual test results now. So at any point in time when you browse this view, you can click on any of the pass and fail icons to get to the actual execution details. So let me go to the test overview again, and let's look at the first failure here that we have for the suite address book. And that brings us to the verification view. And here we can see all the passed and failed verifications. By default, we get a list of all the failed verification. If I click on all, I can also see the past verifications. In this case, I do not have any log messages, but usually it would also show log messages, attached files, warning messages, and so on. Now let's look at this first failure here. we can see that this is a failed comparison. We can deduce this from the failure text. For failures, we also get stack traces here of where in the test script the failure occurred. And we can click on the source location here. So if I click on the first line, which will then open the file view, and that lets us see the test script code that was executed. So we can see exactly what verification was executed and what failed now. So let's go back to the previous view by using the back button. And if we now take a look at the second result here, we see that this is a failed visual verification point. And to see more details about this failed verification point, we can click on this little camera icon here. And that will open the verification point dialog. So right when I open the dialog, I can see a snapshot of the state of the application under test when the verification was performed. In this example, we see one of Squish visual verification points. So it also contains the object hierarchy, which is shown on the side panel here. And when I click on any of these UI elements, they will be highlighted, and a property panel on the right side will open. That shows us some of the underlying properties of the selected UI elements. But what I'm actually interested in why did this verification point fail? And what is the difference between what was expected and what did the test actually encounter? And to see the difference, I can click on the expected visual VP tab down here in the lower left corner. To see what visually changed, I can now quickly go back and forth between the two tabs, or I can use this image slider here to get an idea of what the difference between the two snapshots actually is. In this case, we can see that the input focus was different and that one of the field names didn't contain the expected values either. And we can, if we don't want to compare it visually, we can also cycle through the detected differences with this browse errors section here. So I can cycle through all the elements that observed some kind of difference, be it a screenshot difference, be it a geometry difference, or maybe a property difference. Since the expected visual verification point isn't part of the actual test result, but it's read from the Git repository where our tests are stored, we could also choose to update the expected VP right from within Squish Test Center so that future test runs won't fail for the same reason. This, of course, only makes sense when the changes detected are intentional. For example, when the UI or AOT got adjusted within the last development cycle. But this is really nice and quick way to verify and then update verification points. So I can use this button here. And yeah, then I'm prompted to enter a commit message because you can set up Test Center that to automatically also create the updating commit for you in the Git repository. Then I can just submit. And then on the next test run, this test wouldn't fail anymore. All right, now that we have looked at the details of the test execution, let's look at another important feature of Squish Test Center, which is the history view. So let's go back to the Explore view first. And from the top menu bar, we can choose history. And then maybe pick a bigger time frame, 30 days. In the history view, we get a look at the test results over time. So this can really help us to decide which failures to focus on. So for example, we can see that both suit native type and suit address book were fine in the previous two test runs that we see here. So technically, those are new errors and should require special attention. But we can also see that at least suit address book has failed before. So what we could do now in this view is also compare these two failures that we see on the 19th and on the 16th. So I can choose the compare mode, and then I could look at a side-by-side view and compare if it's actually the same failure. We do not really have the time right now, so I will skip that. Another thing that we can do in the history view, there is a tab here or two more tabs. One is the statistics tab, which can tell you which are the most flaky tests that you have. or which are the tests that are the most broken, or which take the longest time. In this case, the test data is made up, so don't read too much into it. Another tab that we have is the graphs tab. One of the many things that you can look at here and configure is the duration of tests. So you can look at how did the overall test time duration of your test change over time. So this is one thing that you can do on this view. Okay, this concludes this very short overview of the most important test center features. Back to you, Reggie.
Yeah, okay. Can you stop sharing? So I will just share the last slide.
Thanks, Nico. Okay, so during we talked, there were a couple of questions already coming in. We'll try to cover as many as possible. Otherwise, we'll get back to you later because your questions are being recorded. There's one question maybe for you, Tomasz. Are there any plans to integrate Squish with a robot framework?
Actually, it's already possible. So if you go to our knowledge base at kbfroglogic.com, just search for robot framework and you will find a recipe for integrating Squish with the robot framework.
Yeah, thanks.
Okay. Yeah, so then maybe I take one from attendee who's new to Gui testing, asking how fast is the Gui testing Squish, especially compared to unit tests or C++ on unit tests. So Gui tests, of course, are slower since you have to interact, or Squish has to interact with the Gui, but they tests run as fast as it is possible. So you can like switch off the animation of a mouse cursor, and as soon as an element is ready, we will interact with it. So a test runs way faster than you could interact with it as a human, but of course, it still requires your GUI to update and do things. Therefore, it is slower than typically a C++ unit test, which just calls APIs, and which is, of course, a different matter.
But nothing speaks against hybrid testing. So if you have some heavy number crunching tests, do that through a component and do the user's side parts with a GUI testing tool. Okay,
and
so
maybe one question for you, Harri, from one person about Coco, whether we can calculate MCDC code coverage.
Yeah, that question probably came in a tiny bit before I showed that in the end. Indeed, MCDC coverage, which sounds a bit like the name of a rock band, is indeed possible, and it's a very thorough metric that helps you to find hard to find bugs. And I see there's a second question on Coco. What about template code or code in header files? I can confirm that both of them are seen by Coco and analyzed as the tool works on the source code level. So it's not just a binary where that piece of information may be lost, and you can even do a release build where the compiler optimizes. Coco will still handle that.
Okay, I see another question about integrating Squish with IBM Rational Quality Management, so RQM. We implemented an integration there quite a while back, which is used by a couple of our customers directly between Squish and IBM Rational Quality Manager. We are planning to redo, as we did for several other integrations, this through test centers, since that provides much more power than direct integration. But generally, such integrations are available and possible.
Yeah. Reggie, based on what I see, you have been talking about QWidgets and QQuick, but that was always a signal technology. Can you maybe cover those questions that are about other technologies or combinations even?
Yeah, so basically with Squish, you can test different technologies also in a single application. So even if you have like native Windows controls embedded in your application, or whether you have web content embedded. So the different toolkit support packages, as we call it in Squish, then will be pulled in for the right parts of the application. That way you can automate an application which consists of several GUI technologies. So it's of course, within Qt, we support Qt widgets and QML, but also other technologies such as native Windows, web, native mobile testing, and so on and so forth.
And maybe another one, what are the dependencies on the application? Does Squish need the access to the source code, debug information, or anything for it to work?
Yeah. So the simple answer is no. We put quite a lot of work into Squish to be able to hook into an application from the outside without having to modify the application or test. So the only requirement we have for Qt applications is to be linked dynamically against Qt. So with static linking there, you actually would need to link a hook into your application as well, but that's more the exception. Typically for dynamic linking, there's nothing needed to be done in the application, and therefore you can also test the release version of your application, which you really ship to the customers, and you do not need a special build of that.
Thanks. Yeah, the question about the recording of the session, that will be available for you to later look at that with more time. There's another question about IBM tools, integration with IBM change in configuration manager. It's not like we have created direct support for those tools yet, but a part that we maybe have skipped is that all of Squish is based on command line tools. So the IDE that Thomas showed is just a front end to the tools working on the back. And the tools themselves work on plain text files for the test scripts. They generate XML output, optionally JUnit, so you can integrate them actually with any tool that has some way to either provide files or receive test results as JUnit or anything. So our technical support will be able to help with the setup there.
I see another question asking about the underlying technology to identify GUI elements in the application. So due to the rather short time we had for each product, we weren't able to dive deep enough into each of those things. So the way we identify GUI objects is that we can access the whole object tree of the Qt application, as well as all properties and their values. And out of that, we build a so-called multi-property name for each GUI element. So basically, a set of property value tuples uniquely identifies each object in the user interface, and that is stored centrally in a scriptable object map. So that means if there are any bigger changes in your application, you only need to update this object map. But generally, since we use well-defined properties for the identification of the GUI elements, if they are moved around on the screen, there's a different size in there, or things like that, or the number of menu entries changes, for example, this does not impact the identification of a certain GUI element. So that is a rather robust approach.
Question about the Squish version that you will find on the marketplace. It may not have been the very latest version that was just released recently, but we can guarantee that all the Qt versions are fully functional, so there's no stripped down version. And so everything that we saw here and more is available if you get it through the marketplace as well.
So a follow-up question to what I just answered is that we're not using the accessibility interface for Qt. That's correct. So we are hooking deeper into the application and get way more information of the application without direct Qt support. We fall back to accessibility when testing certain native Windows controls or something where no more information is available. But for a technology such as Qt, we build dedicated support, and we do not rely on accessibility, which makes this way more powerful and robust. Okay, I think we are.
Yeah, there's some questions about what this means for existing customers. Details will, of course, still need to be seen, but be assured that part of this deal, of course, is to make things simpler for both of our client bases that can now be merged. Other Qt integrations that were asked for here is we have support for Qt WebAssembly. We are looking at the support for Qt for MCUs now, working in a very basic mode by now. But as usual, and since we have been doing since 2003, we will follow whatever Qt components are available and the platforms that are supported.
And maybe one question for you, Harri, since you're heading the development, how big of a development team do we have?
We try to be developers only, and we did for a long time, but at some point we also introduced dedicated engineers for support, like Reggie, also in charge of sales, but still we are almost only exclusively salespeople on our end, and Reggie, the developer, sorry, that bad mistake here. But yeah, Reggie, actually the total number, like we have 3 teams, one for each for the 3 products that we have, and that is somewhere between 7 or 8 to 4 people per team. But now we are happy to be part of a bigger family and speed up development even more. Okay, but I think we are done now, top of the hour.
Yeah, we are at the end of the hour.
Yes, I think we are running out of time, but I'd like to thank everyone, all our speakers today. And I'd like to thank everyone for joining. If you have any follow-up questions, please email us at info@qt.io or visit that page highlighted on the screen right now. You can leave your contact details there and we'll get back to you. But thanks again and have a great rest of the day.
Thank you.
Thank you.